I'm going to watch and react to this video called The Impending AI Model Collapse Problem by the Prime Time. He's kind of got a reputation of being an AI doomer. To be fair, I have not watched any of his stuff, so I thought it would be an interesting thing to watch together and react to. My friends who suggested it to me also said that he and I would have a personality problem. I don't know what that means, but I'll try to be respectful in the video.
So this actually has been interesting me in some time. I've been wondering if anyone was going to write an article about AIs being fed its own effective data and what happens to it over time. So I am curious what this has to say. Training artificial AI models on AI-generated text quickly leads to the models churning out nonsense, a study has found. Okay. By the way, the visual representations is so good. Look at this thing go. It just gets weirder and weirder. Like, you can definitely see, you can see the two in here, and you just see them slowly die.
I can already see why someone in my comment section wanted me to watch this video. I put a video out a while back about synthetic data, focusing from the standpoint of Google DeepMind and their use of synthetic data for math and reinforcement learning. And in that video, I did say that it was really hard to produce synthetic data for images, which is what we have going on here. So the article that he pulled up looks like it's from Nature, and I'm excited to see what he has to say about it.
This cannibalistic phenomenon termed model collapse could halt the improvement of large language models as they run out of human-derived training data and as an increasing amounts of AI-generated text pervade the internet. What's very interesting about this, and which is part of the reason why I've been betting so hard against LLMs not being the end-all be-all of everything, is this right here, which is that right now, how much percentage of code do you think just last year was generated by Copilot? I bet you a good percentage of GitHub public repos are generated by GitHub. Like a shocking percentage. 10%? 15%? I bet you it's a huge amount.
I don't know. I would be interested to find that out too. I remember watching a video, and I forget who put it out, talking about how code had reproduced, kind of. It found a way to generate its own code. If I can find that, I'll put it in the description. I can't remember whose video that was, but from personal experience, me writing code, oftentimes when I'm using Google Collaboratory, which is a common thing that people use when they're writing code, exactly what I was going to write comes up as the suggestion from Copilot in the box. And I mean, there are definitely some specific times when that is not the case. So it's not perfect by any means, but it surprised me with how good it is. And maybe I should do a video on that.
The dead internet theory, the theory effectively that everything is just bots arguing with bots and all of that. I would not be surprised if ChatGPT 5 is actually harder to make better comparatively than ChatGPT 4 was to 3. I think 5 to 4 is going to be harder, and you'll get less of an improvement than 4 was to 3.
I agree. Not because I think it's true, but because it has mathematically been shown to be most likely. In this day and age, we do have enough information from past models and new models to know that the progression of AI is not, in fact, a linear chart, and it is more of a logarithmic chart. We do have enough data to see the shape of that.
And I think that will keep on happening because I think the availability of novel information and just the degradation of cannibalism will become harder and harder and harder. Not even diminishing returns, because diminishing returns suggests that as you put in, and diminishing returns typically suggest that something along the lines of linear or more, suggesting that the more effort you put in, the less your return is, right?
So yeah, that's what I said the math showed. So I'm interested to see what he is going to say is going to happen instead.
That'd be diminishing returns. My guess is going to be inverse returns, meaning that to make something better is going to be harder.
I mean, I guess in theory that could be true if we are just not progressed far enough on the curve to note a downturn. And if it is going to be with all data like this image that he has on the screen, then probably that would be true. But the results that Google DeepMind has had with using synthetic data for applications other than art is significantly different and showing that it is in fact making a lot of progress. So it would be interesting to see if we break that chart of the progression of AI over time into different kinds of data. It would be interesting to see if all of them have a different slope. I would say probably they will. And it would be interesting to see if images do have the downslope like he was predicting. In the work that I do, we don't really work with image data very often. So I am not an expert on image data. If anyone has experience working with image data and would like to weigh in the comments, I would love to have that conversation with you.
It's just a bunch of deep fried models, because the thing that makes LLMs good is novel content and training on that.
I disagree. The LLMs that we're using right now, Llama, ChatGPT, Anthropic's Claude, basically they're training on a huge subset of data. So there's a significant amount of overlap on what these models are training on. So it is in no way a novel data set because of how huge it is. We can basically say that between all of them, they are training on the entire internet, which is not, by definition, a novel data set. In my expertise, what makes the LLM unique is the weights that it uses in the neural network, and also whatever other features that the LLM might have with it. Like it might have a reinforcement learning algorithm, or it might have a recommender system algorithm, or it might be including some sort of a tree-based framework in with it. Those could all be different depending on which company's product you're using.
Things that don't make LLMs good is LLM stuff, because if that was the case, they would just train themselves. We would be so good. It would just be like, right? Since code can be corrected and self-checked, so a loop of you'd have to create self-corrected loop, right? You'd have to just fully, if that was already a solved problem, we wouldn't even need training data, right? You wouldn't need any more stuff from the internet. You could just let it run and figure out everything.
Not really. That's not how synthetic data works. I'll just put it there. I've gone over this in another video, which I will link in the end screen for you because I've already talked about it. I kind of did on the board some examples of how you could create synthetic data, which is what he's talking about, these images that are basically, we'll call them multi-order derivatives just because I can't think of another thing to call them, where you have the original image, then you have the derivative of that, which is the second iteration of it, and then you can go on down, and that's kind of what the paper was showing. And I showed on the board how to create synthetic data and the difference between using a math data set versus an image data set.
I think we're gonna have deep fried problem, right? There is such a thing as quality of data. We can discuss. We can discuss a cancer research paper.
So yes, there is such a thing as quality of data. I don't remember which one, but one of the large generative AI companies had data come back that was really wrong because they let the model train on the onion, which obviously was not factual information. And one of the problems with the state that we're in right now with large language models is that someone has to figure out a way to separate the shit data from the good data, whether it's by hand of removing that from the data set, which is very tedious, or writing a script to sort it for you, which then of course could be error prone. That's one of the things that synthetic data is hopefully going to fix someday, is that you won't have the problem of it creating the onion type of data. But what he's talking about here, and what this paper that he's talking about is showing, is that it's possible that it could make the problem worse, where we could have data that just gets crappier because it's training on a data set that is flawed.
We can discuss a cancer research paper knowing nothing about cancer and generate 8,000 times more data than the original paper. But everything we have said could be bullshit.
And that's why if you're creating a model, you need the expert on your team that you're creating the model for to look at the product and analyze it before you put it into use. So I would imagine this would be for, a healthcare company. You would want somebody who has an MD after their name. Probably they would be an expert like an oncologist, to look at that and weigh in on whether or not the model you produce is good or not. That's basically how any model of any type works, whether it is a large language model or like a styrofoam model of the planets. Regardless of what model you're making, you have to check to make sure that the model is producing the desired results before you put it into use.
And so that's where things are going to get really interesting, is this entire problem of the snake eating its tail. So this, I'm very curious. I'm curious what they found here. The message is, we have to be very careful about what ends up in our training data, says co-author Zakhar Shumailov, an AI researcher at the University of Cambridge, UK. Otherwise, things will always provably go wrong. Provably? Are you saying that it's mathematically based that LLMs cannot? Are we Ouroborosing hard right now? He says, the team used a mathematical analysis to show that the problem of model collapse is likely to be universal, affecting all sizes of language model that uses uncurated data, as well as simple image generators and other types of AI.
I definitely believe that. Uncurated data is bad. You should never use uncurated data.
That's a pretty big statement, by the way, because
Why?
the internet is so heavily generated content now. The researchers began using an LLM to create Wikipedia-like entries, then trained new iterations of the model on text produced by its predecessor as the AI-generated information, known as synthetic data. Polluting the training set, the model's output became gibberish. The 9th iteration of the model completed a Wikipedia-styled article about English church towers with a treatise on many colors of jackrabbit tails.
That's interesting. I would want to see that. I'm sure that it's linked potentially, since this is a Nature article, in the appendix, so I'm going to try to pull up the article to find that. But this is kind of what I was talking about before, where they use 9th iteration. I used the word derivative before because I couldn't come up with the word iteration. But so they're saying it takes 9 steps of the model training on synthetic data or model created data before it turns into trash. There are some things that we could do to potentially fix that, but all of this right now is hypothetical. There's really no way of knowing if this will happen at a scale like this researcher is saying, where it will happen to everything, or if it will just be on a selected basis, or if it was a process of training the data, or if there's a way you could add a different step in, or different model weights, or a reinforcement learning algorithm, or any number of other things to try to fix this problem, or even that it is fixable, or even that it is an issue. So it's interesting. I'm definitely interested in reading this paper. I am going to pull it up and read it after we're done watching this video.
More subtly, the study published in Nature on the 24th of July shows that even before complete collapse, learning from AI-derived text caused models to forget the information mentioned frequently in their datasets as their outputs become more homogeneous.
So I don't know what they mean by forget. I don't know when this article was published. It says on 24 July, but it doesn't have a year. So I'll have to pull that up and see. But yeah, they're going to forget because they don't have chain of thought. So yeah, I'm not sure that that shows that it's going to collapse. That just shows a limitation of the models that we currently have available to us.
Yeah, it's AI cancer, if you will. That's a fair way to put it. The thing is,
it's not AI cancer. At least not this particular thing. We'll see if something else in this article is. But this particular thing is not AI cancer.
This is like, how do you know, like, inbreeding could be another term. Yeah, inbreeding or cancer. I'm not really sure, because it's almost like it's hard to tell which one it is, because what it produces, yeah, inbreeding might be more accurate in this case. And so,
inbreeding.
I'm curious if Jippity, so my personal guess is Jippity 5.
I now understand why someone said he would bug me. Jippity 5, that's gonna annoy me this entire... He said it correctly before. That's gonna bug me if he keeps doing that. It's GPT, not Jippity. I'll try to let it go.
Now, we may come up with something novel afterwards and get even better. But I think Jippity 5 is gonna be have a huge problem, which is it's going to be good enough that it's used even more, which causes all further information to be some part generated by the LLMs, thus having a problem. Jippity 5 may never exist because of that. Jippity 5 is...
That's an interesting thought. I don't work at Llama or Anthropic, but it would be interesting to see if they're pulling training data that is from those particular sources and to what extent. I'm sure that to a certain extent, there is already AI training on synthetic data. We know that that is definitely true in the sense of controlled experiments that Google DeepMind has run, again, referencing that previous video I did, but I'm sure that there are instances where it has not happened on purpose that we don't know about yet, because it's just at this point it's inevitable that it must have happened. As it happens more often, I guess we will get to know whether it's a problem or not.
Well, they keep Sam keeps mentioning GPT-5, that they're training GPT-5, that GPT-5 is doing these things. He said he was quite certain GPT-5 was going to...
Yeah, someone in the chat putting GPT XD. Maybe it's a thing that's specific to his group. I don't know. I don't like it.
All right, the concern is when making AI models that represent all groups fairly, because low probability events often relate to marginalized groups, says study co-author Ilya Shumailov, who worked on the project while at the University of Oxford, UK.
Okay, I'm interested to know more about that statement, that low probability events relate to marginalized groups. In a way, I can see what it means, because events like discrimination and, you know, other such type of social injustices tend to happen to the marginalized people more than, you know, like white Americans. But I'm not sure if that's what they actually mean by that statement in the paper. He's kind of putting it up in pieces and it's hard for me to get a feel for it. But one thing that I have noted in my study of mathematics is that low probability events, when they are related to people, are clumpy. They happen far more often than they are statistically supposed to. And the reason for that, as shown by Benoit Mandelbrot, who was a French mathematician, is because instead of being a Gaussian bell curve, it could be a fractal. That explains why things like, for example, abnormalities and rare events in the United States stock market happen way more often than they're supposed to. In my lifetime, I'm 36. I have seen things happen multiple times that should probably only happen once every billion years or so. Some people speculate that the reason for this is because humans have emotions.
To understand and be able to identify these rare events as like the real things you should be looking at is extremely hard question. My code is perfect. The OpenAI says US government will get to see GPT-5 before anyone else. You know what that means? Backdoor, baby. Backdoor AI.
No, it doesn't mean it's a backdoor. It means that they're following the law. Wow, novel concept. I've talked about AI regulations and laws on this channel before too. That's a kind of unpopular video, probably because the laws are boring, but I tried to make it interesting. If you'd like to watch it, I will put up a card.
Many technology firms have improved their models by feeding them larger and larger amounts of data, but as human-produced content runs out, they're hoping to use synthetic data to keep improving. The study, a version of which first appeared on the, is that RZIV? RXIV?
Archive. It is the Greek letter chi. So obviously this guy doesn't do research professionally or write academic works. Otherwise he would probably know that. No shade at this guy. I'm just saying, like, bro, it's archive. Also, it says it's a preprint. That means that it is not peer reviewed. I kind of get annoyed by people putting preprints out there and citing them as if they are true because they have not gone through any sort of peer review. They have not been looked at by other experts in the field or critiqued or even accepted into the journal. Be careful if you're citing information that comes from a preprint article.
Large language models work by building up associations between tokens, words or word parts in huge swaths of text, often scraped from the internet. They generate text by spitting out the statistical most probable next word based on these learned patterns.
Basically, yeah, they just go through this whole thing. They take the entire corpus or sentence or paragraph or whatever you give it as the input, and then it one hot encodes it, runs it through a neural network, and then it will add another function onto that, which is basically another layer of the neural net, and it kind of squashes it down from being a giant multidimensional matrix to a 2 or 3 dimensional matrix, which is something that the human brain can deal with. And then it is no longer one hot encoded, and then it sends it through the neural net, and you get the output, which is the statistically most likely word to follow that. Basically, it's like you're taking these different possibilities of what the word could be, and you're linking them, and whichever one has the highest possibility of being the next word will have the output.
Study authors trained their large language models on Wikipedia articles and trained successive generations on the model of the text produced by the previous version, prompted to follow on from a paragraph of text from the Wikipedia entry on grade 1 listed buildings in Somerset. The model's output of the following text. First output of the model, generation 0, contained some errors, but the 9th generation spewed complete gibberish. So model 0.
Yeah, so there is an error term. A lot of these models, there are only so many functions you can use in these. A lot of times, each node is usually a linear regression model, which does contain an error term. Anything you do in life will also have an error term. Like even simple things like I might load the dishwasher wrong and get a broken bowl. That would be the error term. So regardless of whatever you do, you will always have some sort of an error term. So what this means is that model generation 0 had a reasonable error term. And by that, I mean a small error term. And then they're saying that Model 9 had a large error term, which is interesting. Text data, it's tough. It's related to humanity, which can follow emotions. And it's hard to make synthetic data for something that is not mathematical like that.
Revival architecture such as St. John's Cathedral in London, the earliest surviving example of perpendicular revival architecture. Ain't nothing like some perpendicular revival, am I right? Is founded in the 18th century Church of Our Lady of Guernsey, which dates from the late 19th century. There are 2 types of perpendicular churches. Those. Okay, that's a little strange, but okay. 9th generation architecture. In addition to being home to some of the world's largest populations of black double-at-tailed jackrabbits, white double-at-tailed jackrabbits, blue double-at-tailed jackrabbits, red double-at-tailed jackrabbits, yellow-at, classic. Ain't nothing like home to the jackrabbits. So it's never been turtles. It's always been jackrabbits all the way down.
He's showing this article in pieces, but I don't think the researchers are implying that it's always been jackrabbits. I think this is the example that they referenced above.
To demonstrate model collapse, the researchers took a pre-trained LLM and fine-tuned it by training it using a data set based on Wikipedia entries. Now, what would be more interesting is not like, because I feel like this is kind of cheating. Like, honestly, I feel like this study is not as interesting in the sense that people already knew this was going to happen, but B, that's not how the real world looks. The real world looks like some portion of it is going to be AI and some portion is going to be human. So what happens when you're training on data that's 30% AI? Like, how does that really affect the output of these LLMs?
That's not where I thought he was going with his statement that that's not how the real world works. But I do agree with him. And I would be also curious to get an answer to that question of what happens if it's only 30% of it is an AI generated. We can test that by replicating this experiment. But I do, so far, agree with him that the rate at which you introduce synthetic data into the data set probably matters.
Does it actually cause the same model collapse, or does it help tune it into more correctness as we're gently shoving it the correct direction with our edits to its output? Especially if you have the input of the previous one. If that makes sense. If you have if you have the input, the output, and then the fixed, is that good training data? Maybe it's better. Let's see. These researchers took a pre-trained LLM and fine-tuned it by training it using a data set based on Wikipedia entries, then asked the resulting model to generate its own Wikipedia-styled articles. To train the next generation of models, they started with the same pre-trained LLM but fine-tuned it on the articles created by its predecessor.
I am shocked because I agree with this dude. No shade at this guy. I'm sure that he's a very smart guy. He seems like he's very smart. But usually when people send me an YouTube video and said, would you look at this? It's usually something that I don't agree with. So that's why I'm shocked. It's not an insult to this guy specifically. But let's see. So how would I do this differently? They took a pre-trained LLM and fine-tuned it by training it using a data set based on, they asked the resulting model to generate its own. What I thought that he was going to say before, when he said that this is not how real life works, was that real speech and real language doesn't tend to always follow the patterns as are on Wikipedia or any other article. I mean, I haven't tried to replicate this yet, but just based off of how I would run this experiment, I think you would probably have to show it Wikipedia entries and other examples of other types of literature or, language. Because, again, humans and machines think differently. If you give a human this task and say, hey, rewrite this, but make it sound like it came from the same website, we could do that pretty easily. But a machine needs an example of the thing it's trying to create, but also examples of what to not create. Based on my experience of creating AI models, that's how I would change this. Let's see what he has to say.
It's too fast. Model collapsing might not look like this in real life.
And that's another really good point. Like he was saying before, you can't just feed all the new data in at once. You have to potentially have a different rate. So yeah, he's got a good point. You would want to feed it 5% and then run another test where you feed it 10% and run another test where you feed it 20% and run all the way up until you can see at what point does the model collapse. It would be an interesting little experiment to run.
Maybe it's, I wish the study was a little bit more interesting. They judged the performance of each model by giving it an opening paragraph and asking it to predict the next few sentences, then comparing the output of that model trained on real data. The team expected to see errors crop up, says Shumailov. But they were surprised to see things go wrong very quickly. I'm not too surprised. What I'd actually like to see, which I think would be a really interesting idea, is to take GitHub circa 2016 through 2020, take a model, and then fine-tune it on code in this region, code we know that's likely not going to be influenced by any LLM, and then do the exact same thing, maybe not 2022, maybe 2021, and then do the exact same thing again, except for do 2021 through 2024, and then see how does it do on the same set of problems that are proposed afterwards. Which one is going to do better? Like, do we see a degradation of ability to solve problems? Because we know that this contains a higher percentage of LLM code, and this contains virtually none.
Yeah, that's an interesting way of setting it up. You wouldn't know in that data set from 21 to 24 how much of it is LLM synthetic data and how much is human-produced data. If I was trying to replicate this, I would want to have specificity in that. But yeah, he is setting up an experiment correctly. When data scientists like me and probably him, I don't know him, but when data scientists set something up, we do follow the scientific method. And so here he has the control being the 2016 to 2021, and then the experiment being 2021 to 2024. It's an interesting concept, and I hope he does it because I would watch that video.
Yes, you're going to have language version problems, right? Because JavaScript, you can't measure it based on style, like stylistic output. So if you did 2016 to 2021, you're going to get a lot more JavaScript. You're going to train it for a specific area.
Okay, so he's probably a different kind of computer nerd than me if he's using JavaScript. I don't use JavaScript. I use Python, and that's it. Every once in a while, I guess, if I have a biologist that I'm collaborating with, biologists for some reason insist on using R. JavaScript is for software engineering, so he might be a software engineer and not a data scientist. I still would like to see him run this test. It'd be interesting, and I would like to see his results.
And you could do a third test, which would be the combination of both of these, which would be 2016 through 2024. and see, as some sort of, I guess it'd be some sort of control.
He's on the right track here. With that 2016 to 2024, he could potentially infer a percentage, I guess, of data that was synthetic. That's not really the way we do it in statistics. It is an interesting way of approaching the problem.
I guess this would be the control, and this would be, or this is it's hard. These two are the two controls, and this is like the test. And I'm curious to see what happens.
So you have one control and two tests. You have 2016 to 2021 is your control. And then 2021 to 2024 is test 1. And 2016 to 2024 is test 2.
Does it solve problems with the same reliability? Or does problem solving go down? Does it slightly go down? Or does it go up? Like, to me, this would be a much more perfect test. Because this one seems like, this test right here just seems like you are intentionally introducing error into a system. And only error into a system. You have no human intervention.
Yeah, that's another good point. You're going from an error term of probably like 0.05 or less to an error term of 1, which is pretty drastic. So that's another really good point. That would break any model. A high school science volcano. That model would break if you did this type of error introduction. You don't do this in science. So that is another good point.
Collapse happens because each model necessarily samples only from the data it is trained on. This means that words that are infrequent in the original data are less likely to be reproduced, and the probability of common ones being regurgitated is boosted. Complete collapse eventually occurs. Oh, I see. Oh, this makes sense. Complete collapse eventually occurs because each model learns from the reality, but from the previous model's prediction of reality, with errors getting amplified in each iteration.
Okay. Yeah, I was looking at it in the sense of giving an example of minorities. I'll just insert a clip.
this makes a lot of sense why this happens. Over time, those errors end up stacking up on top of each other to the point where models basically only learns from errors and nothing else. Or it would return from only the most common things.
I'm not an artist, but it's almost like the LLM is trying to be a caricature artist, and each different step is sending a caricature drawing to another caricature artist. And that is the best explanation I can come up with for what is probably happening here. In the same respect, though, human art does have a very big standard deviation. So I can also see why the model has trouble training on that.
I have a short that's like literally where I go, okay, so here's the code that it went on, and it's trying to produce like the most statistical likely next value. And that means after all the code comes down, it's just going to be a normal distribution with higher peak into this one area. And then it's going to be sampling from this, which is going to cause even higher peaks of the same thing, right? And we're just going to amplify the statistical most likely middle code. And people are like, clearly a guy that has absolutely no idea about LLMs. I'm like, dude, that's like perfectly what's going on here.
I don't know if this dude and I would be friends in real life, but so far I empathize with him on this issue because I've had a fair amount of people in my comment section telling me I'm an idiot when I'm giving out correct information. But I think that's just the nature of being on the internet, which he should know because he's significantly larger channel than me. But yeah, he's correct. That is how LLMs work. If you don't believe me, then go read a book, I guess. I don't know what to say.